Today, we are discussing modern approaches to software requirements engineering. We will explore how to effectively gather, write, and manage software requirements. Welcome to another lecture from the Programming Professor. Our focus today includes 6 key areas. First, we will understand the core components of requirements engineering. Next, we will compare plan-driven and agile approaches to gathering requirements. Then, we will dive into elicitation techniques, writing functional and non-functional requirements, and creating and analyzing use cases. Finally, we will discuss the importance of validation and maintenance in managing requirements. Requirements engineering involves 4 core activities: elicitation, analysis and documentation, validation, and management. Elicitation is about discovering what stakeholders need from the system. Analysis and documentation organize these needs into a structured form. Validation ensures that requirements meet user needs and are realistic to implement. Management involves tracking changes and ensuring the team remains aligned as the project evolves. These steps form the foundation for project success. They ensure clear communication between stakeholders, reduce development risks, and help the team stay focused on the project scope. There are several methods for requirements elicitation. Traditional techniques include interviews, focus groups, and document analysis, which help gather input directly from stakeholders. Brainstorming encourages creative thinking, while observation provides insights into how users interact with current systems. Modern approaches like interface analysis focus on evaluating system boundaries and how they interact with users or other systems. Process modeling visualizes workflows, while prototyping provides a hands-on way to gather feedback. Workshops and surveys offer collaborative and scalable ways to collect requirements. Writing functional requirements requires clarity and precision. These describe the specific actions a system must perform to meet user needs. Always begin with "the system shall" and ensure requirements are measurable. For example, the system shall allow users to search appointments across all clinics. This specificity helps developers and testers clearly understand what to build and validate. Avoid ambiguous phrasing to reduce misunderstandings and rework. Non-functional requirements address qualities like accuracy, dependability, security, and usability. These do not describe specific actions, but set standards for how the system operates. For example, medical staff shall be able to use all system functions after 4 hours of training. Such requirements are critical to ensuring the system's performance, efficiency, and maintainability. They also guide architectural decisions and influence the overall user experience. Use cases provide a user-centered perspective for defining system behavior. Each use case includes key components: an actor, goal, preconditions, normal and alternative flows, postconditions, and exceptions. These steps provide clarity for developers and ensure stakeholders can validate the design. Use cases also help identify edge cases and potential errors early. An example use case might describe building a tower in a game, with steps outlining how the user selects, places, and pays for it. Validation ensures the requirements are valid, consistent, complete, realistic, and verifiable. A validation checklist helps evaluate these qualities systematically. For example, requirements must meet user needs without conflicting details and should be feasible within technical constraints. Realism ensures that what is planned can actually be achieved. Meanwhile, verifiability ensures the requirements can be tested later. Requirements evolve for many reasons, including changes in business needs, technological advances, and customer expectations. Changes in requirements often occur due to business evolution, technological advances, or customer needs. Maintenance is an ongoing process throughout the project lifecycle. As requirements change, teams must ensure updates are well documented and shared with stakeholders. This helps avoid confusion, keeps the project aligned with current goals, and ensures all team members work toward the same objectives. In summary, requirements engineering is essential for successful software development. Use multiple techniques for elicitation, write clear functional and non-functional requirements, and apply use cases for user-centered design. Always validate and manage requirements as they evolve over time. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more lessons on computer programming and technology. See you next time.